In this video we're going to take a look at the past paper questions for probability. So question number 1, Michael runs a stall at a school fair. His game requires 2 spinners to be spun and allowed to come to rest. That's them shown there. So one of them is numbered 1 to 5, the others from 0 up to 6. The numbers in which the spinners come to rest are multiplied together. To win a prize, the answer has to be less than 5. Calculate what the probability of winning a prize is. For ones like this, when you've got 2 kind of objects, so it could be something like this, it could be a set of dice, and you're then told something along the lines of they multiply together, they add together, something like that. What's quite good to do is set out a wee table. So what I'm going to do is set out a table. One side is going to be one of the spinners and one side is going to be the other, and then I'm just simply going to multiply those together, and that'll give me all the solutions. Alright, so let's do the first one up here. So 1, 2, 3, 4 and 5, and the other one starts at 0. So 1, 2, 3, 4, 5 and then 6, and I'm simply going to multiply all of these together. So 0 times 1, that will all be zeros here in the first row, and then 1 times 1 will be 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4, 4 and so on. 2 times 1 would be 2, 2 times 2 would be 4, 2 times 3 is 6, 2 times 4 would be 8, 2 times 5 would be 10. And then obviously if you think about it, doesn't matter what one has the 5. For example, you've covered 5 times 2, whether that's the 5 on the left and the 2 on the right or vice versa, they both would give the same answer. So 3 times 1, 3, 6, 9. What you realise is what you're doing is really the times tables. 4 times 1 is 4, 4 times 2 would be 8, 12, 16, 20. 5 times 1 would be 5, times 2 would be 10, 15, 20, 25. 6 times 1 is 6, 2 would be 12, 18, 24 and 30. And remember, our game, we had to get less than 5, so let's just circle all the ones that are less than 5. So obviously if it would be any of these zeros here, so that's those ones there, and what else have we got that's less than 5? Less than 5, remember, not equal to 5, so I'm not including that. Okay, so those are the ones circled there. Count how many I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Probability, remember, is the number of favourable outcomes over the total number of possibilities. Favourable just means the thing you're interested in. So in this case, we're interested in the winning number. So the winning number is 13 lots of that. And the total, well, I've got 1, 2, 3, 4, 5, 6, 7. Alright, and 1, 2, 3, 4, 5. So that'll be 13 out of 35 will be the answer for that one in total. Alright, so the total there was 35. And then that's a probability. 35 answers in total, and that's a and there was 13 out of that that would have resulted in a win. So that's the probability for that one. Next question. 6 pupils were asked to choose their favourite subject. The results are shown in the table below. And we've got subject on the left, boys, girls, and then calculate the probability that a boy from this group will choose French as his subject. Alright, so it's the probability that a boy picks French. So what we're looking at is boys, so this column doesn't matter because it's specifically saying a boy, not anybody. Alright, not a person. So what we're looking for, remember, probability is favourable over all the possibilities. And that favourable bit just means what we're interested in. And we're interested in French, and that is 9. So we know the probability is going to be 9 out of the total, which was 66. Okay, simplifying that down, I can divide both of these by 3. So the answer is going to be 3 out of 22, and that's that simplified down as far as we can go. Nice and easy one, that one. Make sure if it says give your answer as a fraction in simplest form, you always do that. Question number 3. Mr. and Mrs. Sybil take part in an onboard lottery which consists of a draw from a set of 32 balls numbered from 1 to 32. First bit we're asked to do is, what is the probability that the first ball drawn has a number greater than 25? So probability, okay, and greater than 25. You can put in the wee brackets here about what the situation is. Doesn't really matter if you don't, alright, but it's just kind of good to do that. So it's a probability that we're getting a greater than 25. Well, if it's numbered from 1 to 32, how many numbers are greater than 35? Well, obviously there's 26, 27, 28, 29, 30, 31 and 32. Okay, so that's 1, 2, 3, 4, 5, 6, 7 in total. Okay, and remember, just to write it down again, probability is favourable over total number of possibilities. Favourable just means the thing you're interested in. In this case, we're interested in winning. Alright, so it's going to be 7. And the total number of possibilities, there's obviously 32 in total. So nice and easy, that's 7 out of 32. Part 2 says, in the draw, 4 number balls are drawn and then not replaced. A further bonus ball is also drawn. What is the probability of the number 9 being drawn as the bonus ball if it wasn't drawn in the first 4? Alright, so in this case, we have started off with 32, and then 4 number balls have been drawn and then not replaced. So my new total is obviously going to be 32 take away 4, so it's going to be left with 28. And then for this one, it's the probability of a number 9 being, drawn out of that 24, out of that 28. And obviously there's only one number 9, so the probability of getting a number 9 is just going to be, remember, favourable over total number. There's only one, and there's 28 in total. So nice and easy for that one. No need to simplify for either of these ones. Alright, question number 4. Anisha and Brian are playing a board game. Each move is determined by rolling 2 dice. Anisha requires a total of 10 or more, on her next roll to win the game. What is the probability of Anisha winning the game on the next roll? Give your answer as a fraction. Alright, so for this one, what we've got here is 2 objects, alright, and this is very similar to question number 1. Right, with something like this, it's dead easy. What to do is set out a table, or it's dead easy to work out the possibilities, all the possible answers. Set out a table with 1 to 6 going one way and 1 to 6 going the other, and then add up those numbers, and that's a nice neat way to work out all the possibilities. Something that you should also kind of point out, for something like this, if there's 6 possibilities on one dice and in the other one there's 6 on the other, alright, the probability for that is actually 6 times 6, or rather the total number of possibilities is 6 times 6, which is 36. It was the very same for question 1. Alright, we had 35 possibilities in total, and there are 1, 2, 3, 4, 5 on that one, 1, 2, 3, 4, 5, 6, 7 on the other. 7 times 5 is 35. Alright, but of course, you're really going to need to go through this process anyway to get the number of outcomes that you are interested in the question. So for this one, set out a table. It goes from 1 to 6. And then this time, instead of timesing, I'm going to be adding these together as I go along. 6, so 1 plus 1 is obviously 2, 2 plus 1, 3, and so on. 2 plus 1 is 3, 2 plus 2 is 4, so on. 3 plus 1, 4, and so on. Again, you'll probably start to notice a wee pattern. 4 plus 1 is 5. 5 plus 1 is 6, and so on. And then 6 plus 1 is 7, and so on. And that's all the possibilities. Alright, and what you can check then, 6 rows of 6, there is 36 in total. And we're interested in there being a score of 10 or more, so let's circle the ones that were 10 or more. Okay, so that's 1, 2, 3, 4, 5, 6. Probability of then getting greater than or equal to a 10. Remember, I don't really need to put in that, but it's just good to have it in. And probability is favourable over total number of possibilities. Favourable in this case is the chance of winning, and there's 6 chances of that happening out of a total number of 36 other possibilities. And we're asked, remember, to simplify this. Sorry, we're asked to give us a fraction, but you're always going to be expected to simplify. I can divide both top and bottom there by 6, so that's just a 1 in 6 chance that that person's got of winning. Alright, next question, last one. Okay, so Mrs. Abid took a survey in a mathematics class of how many pupils travel to school. Of how pupils travel to school. The results are shown in the table, so we've got walk, cycle, bus, and for boys and girls. What is the probability that a pupil chosen at random is a girl who cycles to school? Give your answer in its simplest form. Alright, so what is the probability that a pupil chosen at random is a girl who cycles to school? So we're interested in, remember, so probability, and this is, okay, just girl cycles, and it's favourable over the total number of possibilities. And I should say these were all non-calc as well. So girls that cycle, well, it's 3. Alright, now this question is slightly different. It is the probability that a pupil chosen at random. So unlike question 1, I believe, or question 2 rather, and I'll just show you that. Okay, this one says the probability that a boy from this group. So it's been more specific, whereas this one is just saying that we're choosing a pupil at random. What is the chance that a pupil chosen at random is a girl who cycles to school? So the total is not just going to be the total number of girls, because we're not just choosing out of girls. In this case, we're choosing out of everybody. So the total for this one is going to be all of these added up. We'll just do that on the side. So the total is going to be 2 plus 3 plus 12 plus 6 plus 4 plus 3. 2 plus 3 is 5. That'll be 17. That will be, so 2 plus 5 is 3, 17, 23 plus 7, so that's 30. And then it'll be 3 out of 30. Simplify that down, the question even says to do that, so that'll be 1 over 10, dividing both top and bottom by 3 there. And that's our answer for that one. Alright, so probability, they are problem solving type questions a lot of the time to actually get you. You've got to do something first before you write the probability. You use the kind of equation for probability. So you maybe have a dice game, you've got something, you've got a table to look at. It could be, occasionally it could be a stem and leaf diagram, could be anything. Alright, but for probability, the concept itself in terms of the context can be quite challenging, but what you just need to remember is probability, the outcome, the number of outcomes you're interested in over the total number of possibilities. And if you're asked to do it as a fraction, make sure that you simplify it down as well.